When you have an infinite summation like this, or any kind of summation, I would advise writing down the first few terms. So we're going to get 20 times a half to the 4. I'm going to do this in two different ways, actually. Plus 20 times a half to the 5, and so on, actually, forever. The terms are getting smaller, so we can actually still sum it. 20 times a half to the 4 is the same as 20 divided by 2 to the 4, which is 5 over 4, or 1.25. So it's going to be 1.25 plus 1.25 times a half plus 1.25 times a half squared, and so on. This is an infinite geometric series. The formula is given in the formula book as a over 1 minus r. A is our first term. R is our common ratio, what we're timesing by. This works out really nicely to be 1.25 divided by a half, same as timesing by 2, giving us an answer of 2.5. So when I did it, now I realize I actually slightly overcomplicated it, but it's still worth being aware of this method. I decided to find the sum from r equals 1 to infinity. And then minus r equals 1 to 3. Okay, there are times when this is really useful. I think it's not the best one here. I'm still going to go through it. I kind of end up having to do a similar sort of thing, but this time when I substitute 1 in, I'm going to get 20 times just a half, so I'm actually going to get 10 plus 10 times a half. It's 10 times a half squared, and so on. And then I'm going to be minusing 10 plus 10 times a half, which is 5, plus 10 times a quarter, which is 2.5. So we just get a slightly different thing. My summation now is I'm still going to use a over 1 minus r, but it's going to be 10 over 1 minus a half, and I'll be minusing 17.5. That gives me 20 minus 17.5, and hence the same answer. Okay, so I think probably substituting in, because it's an infinite one in particular, like just substituting in r equals 4 and just treating that as the first term is the best way to go. But I just want to say again, like, knowledge that you can kind of work it out by subtracting two sums is also useful. This second question, we're summing some logs. So again, let's just start it off by subbing in n equals 1, log to base 5 of 3 over 2, plus log to base 5, put in 2, 4 over 3. And we can see they're just going up by 1 each time. 5 over 4, until I get to the final term, log to base 5, when I put in 48, 50 over 49. Now, one method in the mark scheme actually separated the log first into like an addition and subtraction. There are times in maths when that is a really good idea. But here, I'm not saying it's a bad idea, but it's just going to be easier to combine all the logs, actually. Just times them all together now. Times all the numbers inside together using that first rule of logs. Log A plus log B is log AB. So I'm going to get 3 over 2 times 4 over 3 times 5 over 4. It's just going up by 1 every time. I'll get 49 over 48 and 50 over 49. Because the 3's just cancel, the 4's cancel, the 5 will cancel with this respective term. The 48 will, the 49 will, and we're just going to get log to base 5 of 50 over 2, which is log to base 5 of 25, which gives us our answer of 2. Nicely done. Just going to talk about the second method. So I'd get sum from n equals 1 to 48, log to base 5 of n plus 2 minus log to base 5 of n plus 1. And then I can have this in the same summation, but something you can do is instead of like minusing the terms and then summing them all, is you can sum them all separately and then minus them. It's absolutely fine to turn it into this. And now I'm going to sub in the terms, so I'm going to get log to base 5 of 3 plus log to base 5 of 4 all the way up to log to base 5 of 50. Then I'll be minusing log to base 5 of 2 plus log to base 5 of 3 all the way up to log to base 5 of 49. And in a similar way, I didn't actually need to separate into two sums. I've realized I could have kept that separate, but in any case, we can sort of start cancelling these off. The log to base 4 is going to cancel 1. I haven't shown all the terms, but the log to base 49 is going to cancel. It's just the log to base 5 of 2 and the log to base 5 of 50, the highest and the lowest, that are not going to get cancelled, in which case we could combine them. Log to base 5 of 50 minus log to base 5 of 2 back to log to base 5 of 25, and hence 2 that way as well. It's just an alternative. I think the multiplication is the way to go really, but we get there each way. Well done.